Welcome to this video, which is an introduction to ANOVA Part 2, One-Way ANOVA. Let's begin. After watching this video, you should be able to answer the question, why is ANOVA a useful test? Define one-way ANOVA, state the null and alternative hypotheses of a one-way ANOVA test, state the limitations of a one-way ANOVA test, and lastly, list the requirements of a one-way ANOVA test. So, why ANOVA? ANOVA, or analysis of variance, is a method of testing the equality of three or more population means by analyzing sample variances. Its purpose is to determine whether a statistically significant difference among group means exists. Why not use a previously existing method, such as a two-sample hypothesis testing? Well, let's take the example of having 1, 2, 3, 4 different samples. And we want to know if these 4 samples could have come from the same population, or if at least one of them, probably, statistically speaking, came from a different population. Well, to answer that using a two-sample hypothesis testing, we'd have to first compare sample A with sample B. Then we'd have to compare sample A with sample C, then A with D, then B with C, then B with D, then C with D. Oh my goodness, that means that we would have to do 6 different hypothesis tests just to answer this one question. As you can see, that would be very time-consuming, and also it results in a higher alpha or significance level than might be desired. So, what is one-way ANOVA? In this video, we will only discuss one-way ANOVA, which means that only one factor is distinguishing the various populations in the study. For example, if you were comparing the mean height of different plants in a science experiment, you would only change one factor, such as the amount of water the plants receive. Other variables, such as sunlight and plant species, would remain constant. So it's very similar to if when you were growing up, if you ever had to do a science experiment. This is very much how you would conduct the experiment. You would make all of the variables, all of the things that might influence your response variable the same, right? And you would only change one variable. Like in this example, you would change the amount of water you would give a plant. So very similar to that sort of science experiment. We're only changing one variable or one factor. Everything else is going to be the same. So there does exist two-way ANOVA where we change more than one variable, but again, that's beyond the scope of this course. So the one-way ANOVA hypothesis statements are always the same for any one-way ANOVA test. The null hypothesis is essentially this, which says that all the means are the same. Notice that it has mu1 equals mu2 equals mu3 equals ... equals mu(n). So however many samples you're comparing, that's how many mu's you would have in your null hypothesis. Then the alternative hypothesis says that at least one mean is different. So let's just pause for a second and reflect upon what information the alternative hypothesis is giving us and what information is it really not telling us at all. So just pause the video for a minute, just reflect on it, and then unpause it to see if you were right. So notice that if, let's say, I have statistically significant evidence to support the claim that at least one mean is different, do I know which mean that is referring to? I absolutely don't, right? I don't know which sample is different from the rest, or if more than one sample is different, right? And I also don't know how the samples differ, right? So let's say I have 3 samples, right? Maybe the second sample is a lot smaller, the mean is a lot smaller than the other 2, right? Or maybe samples 1 and 2 are much bigger than sample 3. Or maybe 1 and 3 are much bigger than sample 2. Again, I don't know any of that. All I know, just one thing, is that at least one thing is different. That's all I know. And if I want any more information, guess what, guys? Unfortunately, I have to do more tests. I have to either do another ANOVA with a proper subset of the samples, or I have to pick 2 populations and do a 2-sample hypothesis test. I have to do more tests to get more information. So again, the limitations is all this is telling me is at least one thing is different. Kind of like that song, right? One of these things is not like the other. We don't know which one. We don't know how it's different. We just know something's different. Something's not the same. So let's go back to the requirements of a one-way ANOVA. So in my very first video introducing ANOVA, or analysis of variance, I talked about the first 2 requirements. So we already said that the response variable has to be quantitative. Remember, the explanatory variable could be categorical, but the response variable has to be quantitative. And we have to have k simple random samples, one from each of K populations, or a randomized experiment with K treatments. And again, remember, to make ANOVA worthwhile, to not waste our time, we usually require that we have at least 3 samples. Okay, again, otherwise we could use simpler methods and save ourselves a lot of time and bother. So the requirements that we have not yet covered, we haven't mentioned, there's a few more. One is that all the samples have to be independent of each other. Another requirement we have is that the populations in question must be normally distributed. And last but not least, this is the trickiest and hairiest one to test. We say that the populations in question have to have the same variance sigma squared, or the same standard deviation sigma. So it's important to note, and when we get to the video where we're actually testing these requirements with a specific example, this will make a lot more sense. But for now, just note that the standard deviations don't have to be exactly the same. So if one is like 1.2 and one is 1.3, that's okay, right? You're not going to have standard deviations that are exactly the same. But we say as long as the largest sample standard deviation is no more than twice the smallest, we can use ANOVA. And again, this will make this requirement, this metric will make a lot more sense when we get into actual numbers and examples. You'll see how that is applied. So now that you've watched this video, you should be able to answer the question, why is ANOVA a useful test? And again, the answer is that it saves us time when we compare 3 or more populations. We define one-way ANOVA. So remember, one-way ANOVA means that we are only changing one variable and everything else stays the same. We stated the null and alternative hypotheses of a one-way ANOVA test. So the null hypothesis is that all the means are the same. The alternative hypothesis is that at least one mean is different. We stated the limitations of an ANOVA test. Basically, we don't know how the means differ from each other, or which mean is different from which other mean. We just know that something is different. And we listed the 5 requirements of the one-way ANOVA test.